Hi everyone, myself Dr. E. Sridevi, Professor, Department of Electronics and Communication Engineering. In this video lecture, we are going to learn about Biot Savartz law. On completion of this module, the students can able to understand and derive the expression for Biot Savartz law, list the applications and importance of Biot Savartz law, solve sample problems using Biot Savartz law. First, you have to know the Biot Savartz law. And the what is this law states? It is a fundamental law in electromagnetism that describes how a steady state electric current produces a magnetic field. It is formulated by French physician Jean Biot Savart in 1820. In many respects, it plays a role for magnetostatics similar to what Coulomb's law plays for electrostatics. So, the concept behind this law is each small piece of a current carrying wire contributes a small magnetic field. The total magnetic field at any point is found by summing those contributions. So this equation express the magnetic field created by a current carrying wire, and the conductor or wire is represented as vector quantity called current element. The magnitude of magnetic induction at the place caused by the tiny element of a current carrying conductor is stated in this law. It is directly proportional to the current and length of the element and sine of angle between the element and line joining the center of the element to the point. It is denoted as dB equal to mu naught divided by 4 pi into I dl into r cap divided by r square. dB is infinitesimal magnetic field produced by the small element. I is the current flowing through the conductor. dl is the vector representing an infinitesimal length of the wire in the direction of current. R is the unit vector, and r vector is the unit vector, and r is the magnitude of that value. And B of our magnetic field is at this point due to the whole current carrying wire is known as mu naught divided by 4 pi into the overall integration ideal into r vector divided by r square. All are directly proportional I dl and sine theta, and inversely proportional to the r square. So it's the derivation states the current flow is based upon P at any point and distance R of carrying current. This is given us in this diagram. dB equal to K into I dl sin theta divided by R, and dB equal to mu naught divided by 4 pi into I dl sin theta divided by R square. And finally the vector form is given as dB equal to mu naught divided by 4 pi into I dl into R divided by R cube. So the summations are replaced. It will be b equal to overall integral dB vector mu naught divided by 4 pi I dl into r vector divided by r cube. So finalizing, and it will be b equal to mu naught into I divided by 2 pi a. While talking about the applications of Biot Savartz law, the following are the applications. It is used to determine the magnetic response at the atomic or molecule level. It may be utilized in aerodynamic theory to determine the velocity promoted by vortex lines. And the importance of this law is same as electrostatic. Biot Savartz law is used as in magnetostatics. Let us have one basic problem based upon this law. It gives a long straight wire carries a current of 35 amps. What is the magnetic field B at the point 30 centimeter from the wire? So it is given as I equal to the current I is equal to 35 amps and A is equal to 30 centimeter, that is equal to 0.3 meter. So the magnetic field B is equal to mu naught divided by 2 pi into I by A. So substituting these values, it will be mu naught B equal to 4 pi into 10 power 7 divided by 2 pi into 35 by 0.3. While substituting and multiplying, this value is 233 in 0.32 into 10 power minus 7 Tesla. T is for Tesla. So you can write what is Biot Savartz law and what are the applications of Biot Savartz law and what are the importance of this law and limitations of this is it is applicable only for steady state currents, difficult for complex geometries and not directly valid for time varying currents of fields. And this law provides the foundation for magnetostatics. It describes how current elements create magnetic fields and leads to deeper understanding of Ampere's law, solenoids, and electromagnetic theory. So overall, the basic Biot-Savart law is related with magnetostatics, same as that of Coulomb's law related with electrostatics. So using this Biot-Savart law, each and every current carrying element will be act as a conductor. So hope you all understand this session. Thank you for watching.